Good day everyone, my name is Ching Wei. This is my FYP1 presentation and my supervisor is Dr. Anas. My FYP project title is The Simulation Study of Gallium Nitride Based Inverter for Electrical Vehicle Application using MATLAB. So let's start with the introduction of my project. When we talk about eco-friendly, the slogan that first comes into our mind is the 3R slogan. The 3R, which is reuse, reduce, and recycle. There is one technology that able to fulfill the requirement of eco-friendly, which is the electrical vehicle. Electrical vehicle, as its name stated, is using electricity as the power source to drive the vehicle. There are two types of electrical vehicle, which is hybrid electrical vehicle (HEV) and the battery electrical vehicle (BEV). Both types of electrical vehicle able to achieve the emission of carbon dioxide gases near to zero. And in this world, there are one country that has the higher rate of using electrical vehicle, which is Norway. And this is because due to the geography of this country, it has a lot of valley and a sleepy river, so that this country able to build hydropower generator easily. And the cost of electricity in this country is very low. And furthermore, the rate of using electrical vehicle in this country is very high is because of the encouragement of the government. To encourage the people in Norway to use electrical vehicle, the government has been lower all the taxes for the electrical vehicle. Next, to build an electrical vehicle, there are a lot of components inside the vehicle, such as battery, motor driver, inverter, and others power device. An inverter is an most important power device as to convert the energy of in the battery to drive the motor, which is convert the type of electricity from DC current to AC current. Because of this device, it creates a lot of problems such as the low efficiency of conversion and energy conversion. So to solve this problem, in this project, I proposed to use the wide bandgap semiconductor has been chosen to build the base material of the inverter. And the wide bandgap semiconductor that used to build this inverter is the gallium nitride. And the wide bandgap semiconductor is a kind of semiconductor with a very wide bandgap, and its characteristics is very high switching frequency. It supports a high voltage operation, and the semiconductor itself has a high electron mobility. Next is the problem statement of the project. Electrical vehicle is a quite new technology for the human. So researcher and also the consumer also have their own problem to concern. First, the problem that researcher concern is the problem of thermal management of the device. This is because if the temperature inside the device in the electrical vehicle is too high, it will lower the performance of all the device. The next problem that researcher concern is the conversion of energy, which is convert the energy from the battery pack to drive the motor. And the device that do this job is the inverter, which is sit in between of battery and also the motor to drive the vehicle. So the inverter need to be have a very high efficiency of the conversion of energy in order to prevent too much power loss. Okay. So lastly is the problem that consumer concern, which is the overall cost of the vehicle. But by using gallium nitride to build the inverter in the vehicle, it's able to lower the cost about of 10% compared to the most common semiconductor, which is the silicon. Next is the objective of the project. There are two objectives in this project. The first objective is to analyze the performance of the gallium nitride based inverter for electrical vehicle. And next, to compare the performance of gallium nitride based and silicon based inverter. Next will be the scope of work. The first scope will be the output waveform will be directly simulated by using the MATLAB Simulink. The performance such as power loss will be calculated by using the formula through the data obtained from MATLAB Simulink and the datasheet of the MOSFET. And lastly, the target of this project is to compare the performance between gallium nitride based and silicon based inverter. The parameter used to compare are the conduction loss, switching loss, inverter loss, and the switching frequencies. Next is the methodology of this project. The project will be separated into 3 stages. The first stage is the exploration stage, which is explore everything about electrical vehicle, inverter, and gallium nitride semiconductor. The second stage will be build and simulate. In this stage is to test the circuit by using the gallium nitride MOSFET and silicon MOSFET, and also build and test the inverter circuit in the MATLAB Simulink. The last stage is the performance comparison, which is compare the performance of inverter by using gallium nitride MOSFET and also silicon MOSFET. Next will be the simulation software that used in this project, which is the main software is MATLAB and Simulink. MATLAB is a very famous software in among students and also researchers, and the Simulink is a simulation software that based on the block diagram. Okay. Lastly, to simulate the circuit of the inverter, an extension needs to be installed into the Simulink, which is the SceneScape extension. In this extension, it's able to let the user to simulate the electronic circuits. Next is the preliminary result. So this is the inverter circuit that built from MATLAB Simulink. Here is the 6 MOSFET, and it is using 6 MOSFET is because we want to convert the DC current into a 3-phase AC current, and each MOSFET has been already input the parameters for the semiconductor MOSFET, and each MOSFET will be controlled by the gate pulse, and the gate pulse will be the signal generator, the switching frequency of 50 Hz, and with a input pulse of 5 volt, and each phase difference for the pulse generator is different, and in this circuit it will monitor the line voltage of the inverter circuit and also the phase voltage for the inverter circuit. And lastly, the circuit is connected to a 3-phase series RLC load, which is represent the motor that this inverter is going to drive. Okay. So this is the gate pulse of the 6 MOSFETs. We can see that when there are one MOSFET is turning on, other MOSFET will be remain closed. Next, which is the output waveform of the line voltage and the phase voltage. We can see that the shape of the output waveform is almost the same to the sine wave, and 3 signal is in different phase because we need a 3-phase voltage to drive the motor, and the signal is still in staircase loop because of the switching frequency is 50 Hz. So from this waveform, we can observe that the peak voltage for the line voltage will be 347, and our input voltage is 350 volt, is slightly lower than the input voltage, and for the phase voltage is 330 volt. Lastly is the future work for FYP2. In FYP2, I will obtain the output waveform for the inverter for different switching frequency, and the semiconductor they use to compare with gallium nitride will be changed to silicon carbide, and also obtain the losses for each type of MOSFET inverter, and lastly, compare the performance of each type of MOSFET inverter. Okay, that's all from me. Thank you.